Hi friends, welcome back. So still we are seeing the Z-transform. In the next property what we are going to see is linearity property. Okay. Let's see linearity property in Z-transform. Linearity property. What is this? Let's say a signal x1 of n having x1 of z as the Z-transform and ROC is equal to R1, and another signal x2 of n having Z-transform x2 of z, ROC is equal to R2. If I combine these signals x1 of n plus x2 of n, then this is going to give you x1 of z plus x2 of z, and ROC is R1 intersection R2. So you might remember in the Laplace transform also we have seen linearity property. There also the same kind of property we have seen. And here R1 intersection R2, that means common ROC. And there itself we have seen it is not like this. That means first we have to apply, then we have to find out ROC. No, it is not like that. First we have to see whether the ROC exists or not. That means do we have the common ROC or not. If we have common ROC, then only we have to apply the linearity property. What if there is no common ROC? Then we cannot apply the linearity property. First of all, for that signal we don't have any Z-transform. So I can simply say Z-transform does not exist if there is no common ROC. That's what we can say. So if R1 intersection R2 is equal to 0, that is no common ROC. No common ROC. That implies then Z-transform does not exist. Does not exist. So we will never talk about the Z-transform if it does not have the common ROC. Clear or not? Take it. Let's take a question. 1 by 2 whole power n u of n plus 1 by 3 whole power n u of n. Okay. Here for this signal it is a right side signal and pole is equal to 1 by 2. Mod z greater than 1 by 2 is the ROC. For this one, mod z greater than 1 by 3 is the ROC. So I want to see whether it is having common ROC or not. First draw it so that you can understand clearly. So this is a 1 by 3 pole. This is 1 by 2 pole because 1 by 2 is greater than 1 by 3. Now we have to take ROC which is greater than 1 by 2. That means outside this circle, and we have to take ROC which is greater than 1 by 3. That means totally in common ROC is this one. This is the ROC, and for mod z greater than 1 by 3, this is the ROC. So what is the common ROC here? Mod z greater than 1 by 2 is the common ROC. Once we have the common ROC, then we can apply the Laplace transform on both sides. So what is the Laplace transform? 1 by 1 minus 1 by 2 Z inverse plus 1 by 1 minus 1 by 3 Z inverse. So this is so you can simplify it. 2 minus 5 by 6 Z inverse by 1 minus 1 by 2 Z inverse into 1 minus 1 by 3 Z inverse. What is the common ROC here? Mod Z greater than 1 by 2 is the common ROC. Clear or not? So this is the way we can apply the Z transform linearity property. Clear? Take it. Okay. See here, for this signal, what is the ROC? Mod Z greater than 1 by 2. For this signal, mod Z less than 2 by 3. So this is what the ROC. Let's check it out whether they are having the common ROC or not. 1 by 2, 2 by 3. Which one is greater than? This is 0.5, this is 0.66. So this is 1 by 2 pole. This is 2 by 3 pole. So we must have some ROC which is less than 2 by 3 and greater than 1 by 2. That is in between the poles, in between the circles what we are having. So this is what the common ROC. So mod Z lies between 1 by 2 and 2 by 3. So this is the common ROC. Once we got the common ROC, we can apply Z transform. Sorry, here we have written Laplace. It is actually Z transform. Z transform. So you tell me, it is a right side signal. I don't have to change the sign. 1 by 1 plus 1 by 2 Z inverse. And this is a left side signal. So we have to change the sign. Then it is going to be plus 1 by 1 minus 2 by 3 Z inverse. So this is the Z transform. You can simplify it. Okay, so you can do it. I don't want to do it. 1 by 2 less than mod Z less than 2 by 3. Take it. So this is the signal. Let's for this, because it is a left side signal, mod Z less than 1 by 3. It is a right side signal, pole is 2, mod Z greater than 2. If I take pole location 1 by 3, pole location 2. So the ROC is greater than 2. This is the ROC, and less than 1 by 3. This is the ROC. Do we have any common ROCs? No, we don't have any common ROC. So no common ROC, Z transform does not exist. Does not exist. Next, 1 by 3 whole power mod n. 1 by 3 whole power mod n. For this signal we have to see. So this signal can be expanded like this. If n is greater than 0, then it is going to be 1 by 3 whole power n u of n plus. If n value less than 0, then it is going to be minus n. 1 by 3 whole power minus n can be written as 3 power n. 3 power n u of minus n minus 1. So this is the way we can write. Now we can apply the linearity property. So to apply the linearity property, first we have to check what is the common ROC. Do we have the common ROC? Let's see. For this one, what is ROC? Mod z greater than 1 by 3. For this, it is a left side signal. Mod z less than 3. So if I draw this 1 by 3, this is 3. Mod z less than 3, greater than 1 by 3. So that is nothing but in between. This is the ROC. This is the ROC. That is nothing but 1 by 3 less than mod z less than 3. So with this ROC, we can apply the Z transform. So this is going to be 1 by 1 minus 1 by 3 Z inverse. Because it is a left side signal, I have to change the sign. Minus 1 by 1 minus 3 Z inverse. So you can club them 2 into single term, and here mod z is 1 by 3 less than mod z less than 3. So this is the ROC. Clear? Take it. In a similar manner, suppose if I take this signal 3 power mod n, 3 power mod n. This signal can be written as, if n is positive, 3 power n u of n. If n is negative, 1 by 3 whole power n u of minus n minus 1. Okay. For this signal, what is the ROC? Mod z greater than 3. For this signal, what is the ROC? Mod z less than 1 by 3. So let's check it out whether we have the common ROC or not. This is 1 by 3. This is 3. So mod z greater than 3, that means this is the one. Mod z less than 1 by 3, this is the ROC. So do we have the common ROC? No, we don't have any common ROC. No common ROC. If there is no common ROC, we don't have any Z transform. Z transform does not exist. That implies Z transform does not exist. Does not exist. The transfer function of a discrete time control system is h of z is equal to 1 by 1 plus 1 by 2 z inverse 1 minus 3 z inverse 3 z inverse. Find all possible impulse responses. Find all possible impulse responses and comment regarding causality, stability, and existence of DTFT. Existence of DTFT. Okay. So here, how many poles we are having? Two poles. What are they? One is -2, another one is 3. So let's say for -2 correspondingly this is the circle, and for 3 correspondingly let's say this is the circle. For 3 correspondingly this is the circle. Okay. Now if you observe carefully, with this pole pattern we are having 3 ROCs. What are they? One is greater than 3, another one is less than 1 by 2, and between 1 by 2 and 3. So these are the 3 ROCs are possible. So let's say one by one, 3 ROCs. 3 ROCs. What are they? First one, mod z greater than 3. Second one, mod z less than 1 by 2. Third one, 1 by 2 less than mod z less than 3. Less than 3. So these are the 3 ROCs what we are having. Clear? Now correspondingly we have to find out what is h of n, and correspondingly we have to comment on causality, stability, and existence of DTFT. For that, first we have to find what is the partial fractions for this. So whenever h of z is given to you like this, how to calculate the partial fractions for this? 1 plus 1 by 2 z inverse 1 minus 3 z inverse. Okay. So because of inverse, so many people are getting confused. So what I am going to do is first take the z common, so that it is going to be z square by z plus 1 by 2 z minus 3 z minus 3. So this is what we are going to get. Once we got this, please make sure one z is outside. That means z by z plus 1 by 2 z minus 3. Now find the partial fractions for this one. Why we have written z outside this? Because you can understand later. First find the partial fractions for this, then you are going to get z. So this is going to be 1 by 7. So if I say by covering this minus 1 by 2, if I take minus 1 by 2 by minus 1 by 2 minus 3. So this is going to be 1 by 7. Yeah. So here 1 by 7 by z plus 1 by 2. Next, we have to calculate what is the partial fraction for z minus 3. So by covering this z minus 3, we have to place 3. 3 by 3 plus 1 by 2. So that is nothing but 6 by 7. So this is nothing but plus 6 by 7 by z minus 3. This is what we are going to get. Now take z common out, then z get cancelled. Finally we are going to get 1 by 7 by 1 plus 1 by 2 z inverse plus 6 by 7 by 1 minus 3 z inverse. This is what we are going to get. So because this is in the standard form, so now we can write what is h of n. So this is what h of z. First you can take this one, then we can write the inverse z transform. 1 by 7 by 1 plus 1 by 2 z inverse plus 6 by 7 by 1 minus 3 z inverse. This is what h of z we got after partial fractions. So we are having 3 ROCs. Let's see one by one for different ROCs what we are going to get. First one, mod z greater than 3. Mod z greater than 3. So mod z greater than 3 means, let's say this is minus 1 by 2, this is 3. So mod z greater than 3 means this is the ROC we got. So for both the poles, it is a right side signal we have to write. So right side signal means h of n is equal to, for this what is the right side signal? Minus 1 by 2, because minus 1 by 2 is the pole, whole power n u of n plus, sorry, we are having 1 by 7 also, h of n is equal to 1 by 7 multiplied 6 by 7 3 power n u of n. And to comment about the causality, yes, definitely it is a causal. Why? Because ROC is outside to the outermost circle, so it is a causal. Next, to comment about the DTFT and what we can say stability, we have to see where the unit circle is present. Is it present in the ROC or not? So where is the unit circle actually? That is here, right? 1. So this is the unit circle. So unit circle is not there in the ROC. So whenever ROC does not contain unit circle, then we can say DTFT does not exist and it is unstable. So we can conclude causal, unstable, DTFT does not exist. Does not exist. These are the conclusions we have made. Next. Next case, mod z less than 1 by 2. Mod z less than 1 by 2. So here, let's say how it is going to look like. Minus 1 by 2, 3. So mod z less than 1 by 2 means this is the ROC we have considered. So for this ROC, both the signals we have to write is a left side signal. So what is h of n? H of n is equal to, left side signal means we have to change the sign. Minus 1 by 7 minus 1 by 2 whole power n u of minus n minus 1 minus 6 by 7 3 power n u of minus n minus 1. So now we have to check whether it is a causal stable DTFT exists or not. So we have to look at where is 1. So still we don't have unit circle inside the ROC. So I can decide that it is a non-causal. Why it is non-causal? ROC is not outside the outermost circle, so it is a non-causal. Second one, unstable. Why it is unstable? Because ROC does not contain unit circle. Third one, it is DTFT does not exist. Same reason. Does not exist. Next, third case. 1 by 2 less than mod z less than 3. So this is the ROC, in between ROC. This is the ROC. So I can say with this ROC, for 1 by 2 minus 1 by 2 we have to write right side signal. For pole 3 we have to write left side signal because it is inside. So h of n for minus 1 by 2 pole we have to write a right side signal. So it is 1 by 7 minus 1 by 2 whole power n u of n. Next, for 3 pole we have to write left side signal. So we have to change the sign. Minus 6 by 7 3 power n u of minus n minus 1. So this is the signal. Now we have to comment on causality, unstable, stable, DTFT exist or not. So for that we have to take unit circle, reference circle. Now ROC contain unit circle. That means definitely it is a stable and DTFT exist. And it is a non-causal system because ROC is not outside the outermost circle. So non-causal and it is stable and DTFT exist. DTFT exist. Clear or not? Take it. In Z-Transform, let x of n is absolutely summable signal. Absolutely summable signal. Its Z-Transform has two poles and two zeros. Two zeros. Poles are at z is equal to plus or minus 2. Then which of the following is true? Which of the following is true? Option A. It is a finite duration signal. Option B. It is a causal signal option C. It is a non-causal signal option D. It is periodic signal. So poles and zeros, two poles, two zeros, and those two poles are given. Sorry, this is not plus or minus 2, it is plus or minus J2. Please make a change. Plus or minus J2. Then which of the following is true? This is plus or minus J2. Okay. Okay. Let's see. First of all, where the poles are located, we can see that. So J2 here, minus J2 here. Correspondingly, we are having a single circle only. So this is a J2, this is minus J2 because radius 2, right? So radius 2 means it is having, both poles are having single circle only. Now single circle means we may have two ROCs, maybe outside, maybe inside. Which ROC we have to consider? That means they have given one clue there. That means absolutely summable. That means summation mod x of n is equal to minus infinity to infinity is less than infinity, absolutely summable. That means it is a condition for DTFT convergence, or we can say it is a condition for actually stable system. Okay, so if it is a stable system, then we can say stable. That implies ROC must include unit circle. Unit circle. Where is the unit circle here? This is the unit circle, right? This is the unit circle. So ROC must include unit circle means it must be ROC like this. This is the ROC we have to consider. So this kind of ROC is going to give you a causal signal or non-causal signal. That is definitely non-causal signal, left-sided signal. So it is left-sided signal. That is non-causal. So option C is correct. It is a non-causal signal. And next, differentiation property. Differentiation property. What is this differentiation property? Let's see. If x of n having Z transform x of z with ROC is equal to R, then n x of n having Z transform minus z dx of z by dz. ROC does not change, which is R only. Let's make you understand by an example. n a power n u of n. For this, what is the Z transform? Let's see. We know a power n u of n, which is 1 by 1 minus a Z inverse with ROC mod Z greater than mod a. N a power n u of n. Then we have to say minus Z d by dz of this quantity. This quantity can be written as 1 minus a Z inverse whole inverse. Okay, that is equal to minus Z into minus 1 minus a Z inverse whole power minus 2 into differentiation for this one, minus a minus into minus plus a Z power minus 2. So finally minus minus get cancelled, Z 1 Z get cancelled. Finally a Z inverse by 1 minus a Z inverse whole square. So this is what we are going to get, and you have to remember this. For mod Z greater than mod a. Suppose if I take n plus 1 a power n u of n, what I am going to get? This can be written as n a power n u of n plus a power n u of n. For this, if I apply Z transform, then what will happen? This one is just now we have calculated a Z inverse by 1 minus a Z inverse whole square plus 1 by 1 minus a Z inverse. If I take 1 minus a Z inverse whole square as LCM, then a Z inverse plus 1 minus a Z inverse. A Z inverse get cancelled. Finally, we are left with 1 by 1 minus a Z inverse whole square with mod Z greater than mod a. And these two results are standard. You have to remember them. Clear? Take it. A power n u of n having Z transform a Z inverse by 1 minus a Z inverse whole square mod Z greater than mod a. N plus 1 a power n u of n having 1 by 1 minus a Z inverse whole square mod Z greater than mod a. And we know a power n u of n also 1 by 1 minus a Z inverse mod Z greater than mod a. These are the standard results you have to remember. Standard. Let's see a property which is central ordinate property. What is the central ordinate property? Try to understand. We know x of z, right? That is summation n is equal to minus infinity to infinity x of n z power minus n. at z is equal to 1, at z is equal to 1, x of 1 is equal to summation n is equal to minus infinity to infinity. When z is equal to 1, this is nothing but summation x of. So summation x of n is going to give you x of 1. X of 1. I hope you understood. Take it. Based on this, let's say one theorem. So based on these formulas and based on this central ordinate, let's give you summation n is equal to 0 to infinity n a power n, n a power n is given to you. Okay. So by seeing this formula, so many people think that it is going to be a mathematics, but it is not. Why? Let's say this can be written as summation n is equal to 0 to, sorry, n is equal to minus infinity to plus infinity n a power n u of n. We can write like this. If I remove this u of n, this is going to be 0 to infinity. So I can say this is x of n. Then can I say this is x of 1? That means if you know x of z, in that we have to place n is equal, sorry, z is equal to 1. For this signal x of n, n a power n u of n, x of n. What is x of z? X of z is equal to a z inverse by 1 minus a z inverse. Then what is x of 1? When z is equal to 1, then this is, sorry, whole square. This is a by 1 minus a whole square. So that is the formula we got. Clear or not? Take it.